All right, folks, here is your video answer key to the homework for today. I'll go through each one. When you look at problem number one, it says the square root of x squared. And as we talked about in class again today, was that you look at the variables and you find the exponent. And if the exponent is even, it means it's a perfect square. And you simply take half of whatever that even exponent is, and that's what comes out of the square root. So the square root of x squared is simply x. That's, and you remember, why is it just x? Well, you remember it is x to the first power, which is half of 2, but we don't write that. We just write x. Next problem is the square root of y to the 5th. So again, let's look at that. And we look at 5. That is not an even number. So it is not a perfect square. However, we can rewrite this as the square root of y to the 4th times y to the 1st. So if we remember when you multiply exponents with the same base, you add those exponents. So that is the same thing as y to the 5th. And then you can look at 4. 4 is an even number, which means it's a perfect square. And so half of that, the square root of y to the 4th, is half of y to the 4th, which is y to the 2nd power. And what's left behind? The square root of y. And we talked about it when we're doing these, and we are finding and rationalizing variables, and we have an odd variable. We have a variable with an odd exponent. We always leave behind one of those variables under the square root sign. All right, number 3. First thing we want to check is 6 an even number? It sure is. And so that means it's a perfect square. And so we simply say, what's half of 6? It's 3. So what's the square root of m to the 6? It's m to the 3rd power. All right. Now let's get a little more complicated by dealing with combinations of numbers and variables. There's lots of ways that we can do this, but the first thing I always want to see is, are there perfect squares already underneath our square root sign? And in this case, yes, both 16 and c to the 2nd power are perfect squares. 16 and c to the 2nd power are perfect squares. So square root of 16 is simply 4. Square root of c squared is c, because 2 is an even number. We take half of that and we pull it out. 4c would be our answer to number 4. Now let's look at number 5. Number 5, these are not, well, are they both perfect squares? No. Is one of them a perfect square? Yes. So you have the x to the 2nd power here. That's a perfect square because 2 is an even number. But when you go ahead and look at the 75, it's not a perfect square, but it has perfect squares in it. So I'm going to go ahead and break this up into 2 separate square roots to help us out a little bit, just to see it like that. There's different ways we can do this, but this is one way to write it. Now let's simplify. What is the square root of x squared? Well, the square root of x squared is x. And then we have to figure out how to simplify 75. And so what's the biggest perfect square that's in 75? Well, after you go ahead and list the possibilities, you have 75 times 1. 2 does not go in there. You have 25 times 3. And we also have 15 times 5. Well, your best option here, and your only perfect square that I came up with, is 25. So let's go ahead and write the square root of 25 times 5 here. And what's the square root of 25? Whether you know this one by heart by now or you have this in your sheet, the square root of 25 is 5. And so our next step is to bring out the 5. Put that in front of the x. The number always goes in front of the x. What's left behind? Simply 5. Another one. Okay, so is 99 a perfect square? Nope. Is k to the third a perfect square? Nope. So what's left behind? We have to figure out what perfect squares are in there. So let's go ahead and split these into two. Simplify things a little bit for us. And, well, k to the third, let's take care of the variables first. Well, the biggest even number that's close to 3 is going to be 2. And so I can break this down into k to the second power times k, and which in the end means that I'm going to be able to pull out 1k, which I'm going to put over here, right? And what's left behind is simply a k as well. And let's deal with 99. Well, 99 times 1, 33 times 3, and 11 times 9. Well, of those, what is the perfect square? 9 is. And so let's break this down into 9 times 11. What's the square root of 9? It's 3. Let's put that in front of the k. What's left behind? 11. Now we got to smush these together. And we smush these together by leaving the 3k on the outside. Square root k, square root of, sorry about that, not k, square root 11 times k. There you are, folks. All right, couple more quick ones. You're getting this by now, I'm sure. All right, so number 8. Well, square is 64 perfect square. We check our chart and it is. Is x to the 9th a perfect square? It is not, because 9 is an odd number. Let's break these into two parts to help us out. Well, the square root of 64 is 8. We can break the square root of x to the 9th as x to the 8th times x. What's half of x to the 8th? Well, it's x to the 4th. What's left behind is simply an x. So 8x to the 4th, square root of x, is your final answer. All right, last problem. Square root of 5x to the second power. Well, is 5 a perfect square? No. X to the second is a perfect square, so let's go ahead and break these up. Make it a little easier to see. What's the square root of x squared? Well, that's x. What are the factors of 5? Well, they're simply 5 and 1. There's no other way. It's a prime number. So what do we do in this case? We bring out our x, we leave our 5 behind, and we are finished. Our answer to that one is x square root to the square root of 5. All right, I hope this was helpful. Make sure you have your answers correct and submit this as soon as you're done.